Hello everyone, welcome to ACE Engineering College YouTube live session on software engineering. Myself Dr. Prem Kumar, faculty of ACE Engineering College, which I am going to discuss about software engineering, fundamental design concepts. So that is design engineering, design concepts and principles. What is the need of design? Which you already aware, SDLC phases. What is the role of design in SDLC phases? SDLC stands for software development lifecycle phases. So what is the role of design in this SDLC? Let's list out what are the various SDLC phases. Planning and risk, requirements and analysis, design, implementation, testing, after testing, deployment, and maintenance. For development of any software system, the software engineering team has to follow this SDLC phases, software development lifecycle phases. So when the team is following this SDLC phases, one of the phase in SDLC is of design phase. So what's the importance of design? Design importance is to prepare the blueprint for the software system, Among all SDLC phases, which phase is giving solution for the software system? So this design phase is giving solution for any software system. When the team is working on software projects, the designers, architecture level designers, software designers, they are giving solution for this particular software system. That's why design plays major role. So the designers, when they are going to design a software system, what are the design concepts, what are the design criteria which they are supposed to follow to model a software system or to design a software system? That we'll discuss in detail, right? So design and quality. So design must include all explicit requirements and implicit requirements decided by the customers. Now observe the SDLC, the design of a software system, to prepare blueprint for software system. So based on the requirements which is given by the clients, based on the requirements only, the designers, they have to design a software system. Once the requirements were gathered from the client, the gathered requirements supposed to be thoroughly analyzed. What's the purpose of analysis here is to remove the contradictions, ambiguities, incompleteness. After that, one document will be prepared. Name of the document is SRS document. SRS stands for Software Requirement Specification Document. What exactly this SRS consists of in it? SRS consists of client requirements. Might be implicit requirements or might be explicit requirements. This is what? Implicit requirements or might be explicit requirements which is given by the client, right? So that means to say design must include all the explicit requirements, implicit requirements decided by the customer. When the customer is given requirements to the development team, right? Project analyst directly goes to client company, gather the requirements, and after that analysis has done. Based on that, SRS document was prepared. Based on this SRS document only, design should take place. That is what? Design must include all the explicit requirements and implicit requirements decided by the customer. So what are the requirements which were specified by the client or customer, that which were specified in the SRS document? All those, yes, based on the SRS document only, design should take place. So that is what one of the first point, that is about design and quality. Design must include implicit and explicit requirements which is given by the client. Next one is design must be readable. Why design must be readable? Because design should be better understandable by the whom here, who will do implementation here? Programmers, right? Programmers or developers, they'll generate source code, right? So once the design has done by the designers, they prepare blueprint for the software system. They design the model of the software system. The design model supposed to be better understandable by these programmers or developers. Then only they can generate proper source code. So that is what here design must be properly readable by other stakeholders. Might be programmers, might be again designers, might be other stakeholders, right? So that is what design must be readable, right? Coming to next, quality guidelines. As a designer, when they are going to design a software system, they supposed to follow these quality guidelines. Then only their design model can maintain a quality. Otherwise, what will happen? Once the designers, they have designed a software system, but which is not maintaining quality, what will happen? So the client cannot satisfy, simply the design model can be rejected by them. That's why the designers, while designing a software system, they should follow quality guidelines so that their design model can maintain quality, so that client can satisfy. So that's why the quality guidelines plays major role. So what are the various quality guidelines? Design should be modular. What is mean by modular? What is the need of modularity? So large complex software system gets divided into multiple modules. Again, modules gets divided into small components. That means to say, reducing the complexity of the large complex software system. That is what the purpose of modularity or modular. So design should be modular. That means to say, let's see here. This is what large complex software application. Large complex software application, right? Large complex software application, right? Which gets divided into modules. That is module 1. Module 1. We call it as module 1, right? And this is module 2. Module 2, right? Module 3. Module 3. This is module 4. Module 4. Let's take here large complex software application gets divided into 4 modules, right? So that the module size is small, so that the designers and developers, they can easily understand, they can easily design, the developers, they can easily develop, is it? So that is better understandable by them. They can easily design, develop, they can easily test. So these are all the advantages of dividing a complex application into small modules. That is what the purpose. That means to say, design should be modular. So design model supposed to be in the form of various modules, so that the designers, they can easily understand it, they can easily design it, which can be easily understandable by the programmers. They can easily generate some source code. That is what the advantage with modularity, right? Design must contain distinct representation of data, right? Architecture, interface, components. So we know what is the importance of the large complex application gets divided into modules. Again, modules gets divided into small components. So what is component? Physical replaceable part of a software system is called as component. So that means to say, the component size is very small, so that the designers, they can easily design the small components. As a developers, programmers, they can generate source code, testers, they can easily test it. Again, those supposed to be integrated. So how those again components supposed to be integrated, combined? By using interfaces. That is what the purpose of here, interfaces. So design must contain distinct representation of data, architecture, and interfaces required to combine components, as well as here modules also, right? Next, design should lead to data structure. So design should lead to data structure. Why design should lead to data structure? So the designers, when they are designing a software system, they are supposed to use one of the modeling language, right? What is the name of the modeling language? UML. UML stands for Unified Modeling Language. So why this UML became popular? Because UML is one of the object-oriented modeling language. As a designer, if you want to design a software system by using UML, your design model can be represented in the form of objects and classes. Why object-oriented design of a software system became popular? Because object and class size is very small, so that designers, they can easily design it, developers, they can easily generate source code, that is can be testers, they can easily test it, which is easily which is easily testable, is it reusable, replaceable. That's why object-oriented UML is one of the object-oriented modeling language which became popular. So design should lead to data structure, so that what are the classes which were designed by using UML. So entire software system, is it? So that's supposed to be designed, that is in the form of UML diagrams. So one of the diagram is class diagram. So that what is the classes for that particular software application which was designed with the class diagram. Those class diagrams supposed to be implementable by the programmers. So that is what here design should lead to data structures. Next is design should lead to interfaces that minimize complexity. What is the purpose of interface? Just now we had discussed large complex software application gets divided into what? Modules. Again, modules gets divided into small components, right? Components were designed, developed, tested independently. Later, those small components supposed to be integrated, combined. How to combine here? By using interfaces, right? So design should lead to interfaces that minimize complexity, right? Next is design must be derived by a repeatable methods. So when the designers, they are designing a software system, they can use repeatable methods to provide better quality, right? Design must be represented by a notation. Why design must be represented by a notation? The reason here is other stakeholders, they supposed to understand your design model in a better way. If it is represented in the form of graphical notation, so that other stakeholders, they can easily understand the design model of your software system. Why UML became popular? Unified modeling language, one of the object-oriented modeling language which can design a software system and which can represent the software system, that is in the form of graphical notations, so that other stakeholders, they can easily understand it. That's what one of the design guidelines. Design must be represented by a notation, means graphical notation, right? Next is design must represent an architecture. Design must represent an architecture. So what is architecture? What this architecture consists of? Any software architecture is a collection of components, interfaces among components. That is what the importance of architecture. Next, we are going to discuss about design principles. What are the design principles? When the designers, when they are trying for designing a software system, what are the principles supposed to be followed by them so that they can design a quality software system? So what are the various design principles? These design principles supposed to be kept in the mind of designers while designing a software system, so that the designed software system can maintain quality, then which can be satisfied by the clients. So that's what the purpose of design principles. Let's see. Design should not suffer from tunnel vision, means narrow-minded vision. The designers, when designing a software system, they should not think narrowly, they should think broadly while designing a software system. If they think narrowly, the quality might not be maintained, right? They have to think broadly, and based on that, they have to design a software system. That's why one of the design principle is design should not suffer from tunnel vision. Tunnel vision means narrow-minded vision. Who might have narrow-minded vision here? The designers, right? So when they are preparing blueprint for the software system, is it? They have to think broadly, right? They should not think narrowly. Design must be traceable to analysis. What is meant by design must be traceable to analysis? Just now we had discussed SDLC phases, software development life cycle phases. So where exactly design must be traceable to analysis? Based on what design of a software system will take place in SDLC phase, software development life cycle phase. So first phase of SDLC, just now we had discussed, is it planning and risk. Second phase is requirements and analysis. Third phase is design. That means to say, from requirements and analysis only design should take place. Design must be traceable to analysis. So requirements and analysis phase, after analysis, which document will be prepared? SRS document, software requirement specification document. Let's see, I'm not writing all SDLC phases, only just 3: planning and risk, requirements and analysis. This is what design. This is implementation. Let's see. There are various other phases also there, which we already discussed. Right. So what is the design principle? One of the design must be traceable to analysis. So design supposed to be taken place from requirements and analysis phase only, based on requirements and analysis. After gathering requirements should be analyzed. So what's the purpose here? To remove contradictory requirements, to remove ambiguous requirements, to remove incomplete requirements. After discarding all those requirements, SRS document will be prepared, software requirement specification document. Based on that only, design should take place. So design must be traceable to analysis. So from analysis phase only, design should take place. That is what one of the design principle. Design should not reinvent the wheel. That means to say what? So when the designers, they are designing a software system, they should not include their new ideas without previous phase, right? What exactly given in the requirements and analysis phase, what exactly this SRS document consists of, requirements which is given by the client. Based on that only design should take place. Designers should not design their own design model based on their own ideas. That is what the meaning of design should not reinvent the wheel. That is what the meaning of design should not reinvent the wheel. Designers, while designing a software system, they should not design the software system based on their own ideas. They have to design a software system based on the requirements and analysis, based on the SRS document, based on the client requirements. That is what one of the design principle. That is what one of the design principle. Design should exhibit uniformity and integration. Design should exhibit uniformity and integration. So we already discussed it. Large complex software system gets divided into modules, design modules. Those supposed to be integrated, is it? While integrating, is it clear some inconsistency, interface inconsistent related problems should not occur. That is what design should exhibit uniformity and integration. Design is not coding. Just observe here, SDLC. Is it design and coding same here? Implementation, or another name we call it as coding. Right? Next phase. After this what? Testing will take place. That's a known thing to us in SDLC. Right? So this is what SDLC, software development life cycle phases. After testing, deployment of software application to the client. Next is of maintenance. Right? Now observe here. One of the design principle, design is not coding. Definitely design is not coding. So design phase is different, coding phase is different. After design only, coding should take place. Based on the design model only, programmers, they have to generate source code. That's why one of the design principle is design is not coding, right? Design must take care of quality. Definitely design must take care of qualities. The designers, why here design phase is giving solution for the software application. Is it? Designers, they are giving solution. When the designers, they are giving solution, design must maintain quality, must take care of quality. Designers, they should take care of quality, because design, in the form of design only, solution should be given for the developed applications. Design should be structured to accommodate changes. So what are the changes which is given by the client? Those supposed to be accommodated. Is it frequent changes which is given by the client? Next, we are going to discuss about fundamental concepts in design. This is one of the important concepts. What are the various fundamental concepts in design? Explain in detail about them. One of the long question, right? So we will discuss about this. Fundamental concepts in design. So abstraction, one of the fundamental concepts in design. Next is of architecture, patterns, modularity, right? Information hiding, functional independence, refinement, refactoring, right? So these are the fundamental concepts in design. Let's see. Abstraction, architecture, patterns, modularity, information hiding, functional independence, refinement, refactoring, right? So what is abstraction? Abstraction. What's the importance of abstraction? High level abstraction, low level abstraction. High level abstraction, which is not providing in detail description about that particular design model of a software system. Whereas low level abstraction, which is giving more detailed, right? Abstractions were classified into two categories. Procedural abstraction, next one is of data abstraction. So what is the importance of this procedural abstraction? What is the importance of this data abstraction? Procedural abstraction, which represents set of instructions which is required to perform some operation. Whereas data abstraction, which represents some data object. We'll take one example for this procedural as well as data abstraction. Procedural as well as data abstraction, right? So example here is open the door, right? So what is procedural abstraction here? So here to open a door, right, some procedure supposed to be followed. So reaching to door and grab the knob, open the door. That is what comes under procedural abstraction. So open is the example for what here? Procedural abstraction. To open a door, so you have to follow some set of instructions, which comes under procedural abstraction. And what is your data abstraction? Data abstraction represents data object. So what is the data object here? Door is the data object. So example for data abstraction here is door, right? So this is what about abstraction. Right? Coming to architecture. What is the architecture represents? So architecture represents here, software architecture is a collection of components and interfaces among components that we call it as software architecture. Right? So about this we'll discuss in detail at anyhow. Next is about patterns. What is the importance of patterns? Why patterns? Design patterns requires. Why patterns requires? Is it? So if you want to give, as a designers, if you want to give what here? Ready-made solutions, right? Then patterns required. Patterns provide ready-made solutions, right? When the designers, they are designing a software system, right? They need some solution, ready-made solutions. That's it. So ready-made solution is nothing but already built-in solutions, already available, right? So they directly use in their design model. So what is the advantage with patterns? Patterns will give ready-made solutions to the designers as well as for the developers, right? For the developers, when they are generating source code, they no need of developing the components from the scratch. Already components were already developed for already existing projects. From the existing project components, directly they can reuse in their proposed new project. What is the advantage with that? The time required for developing a new component is what here? Less. That means to say the time is with less time, with ready-made solution, they can complete their development. So that means to say design and development time and cost will be reduced. That's why patterns plays what here? Major role here. Patterns will give ready-made solutions immediately so that design of a software system can be done quickly with less cost. Development of a software system can be done quickly with less cost. So that is what the importance of patterns. Giving ready-made solutions, right? Coming to modularity. So what's the importance of modularity? Why the large complex software system suppose gets divided into modules. What's the reason? Briefly we had discussed in the just now we had discussed briefly about modularity, right? So what is the need of modularity? Why large complex software system supposed to be gets divided into modules? Because large complex software system cannot be better understandable by the designers, developers, or other software engineers, because the size of the software application was, is it complex and too large. What is the solution to better understand here? Divide the large complex applications into modules, small parts, so that the designers, they can easily understand it, is it? So that the designers, they can easily design, is it? So that the developers, they can easily understand the modules, they can easily implement it, testers, they can easily test it, and that is what the purpose of modularity. That is the purpose of modularity, is it? So here, large complex applications gets divided into modules, is it? Again, modules gets divided into small components, so that designers, developers, they can easily understand, they can easily design and develop, the testers, they can easily test it. So that is what the purpose of modularity. Coming to information hiding. So what's the importance of information hiding? That we'll discuss here. Let's take here, this is what module 1, large complex software application was, it gets divided, for example, module 1 and module 2, right? Module 1 and module 2. What is the purpose of this information hiding? Wants to communicate with module 2 with the help of interface. So how these two modules can communicate? How these two modules can communicate here? So these two modules can communicate by using interfaces. This is what we call it as interface. We call it as interface, right? So what's the importance of here information hiding? What is the importance of information hiding? What is the importance here? Module 1 wants to share some information to module 2. So module 1 supposed to share only necessary information, not detailed information. Only necessary information or necessary data. Necessary information or necessary data. Is it? Only necessary data, not detailed information. So that is possible by this information hiding, right? So module 1 wants to share only necessary information to module 2, right? But module 1 don't want to share in detailed data of module 1 to module 2. So that is possible, that is achieved by this information hiding. That is what the importance of information hiding. That's the importance of information hiding. Coming to functional independence. What is the importance of functional independence? How to achieve functional independence? So functional independence, about this functional independence, we'll discuss here. So that functional independence can be discussed by using here two attributes, that is coupling and cohesion. What is coupling? What is cohesion? That we'll discuss here. So which one achieves functional independence? That we'll discuss, right? So what is coupling? What is cohesion? Let's take here, there are two components, component 1, component 2. Component 1, component 2. What is coupling? When component 1 performing some operations, while performing which is depending on component 2. Similar way, when component 2 wants to perform some operation while performing which is depending with component 1. So this dependency we call it as coupling. Means component 1 is depending on component 2, at the same time component 2 also depending on component 1. This we call it as coupling. Then what is cohesion? Let's take one component, single component, component just C. Component name is C, right? So when this component wants to perform its operations, the component C is performing its operations on its own without depending with neighbor components. So such concept that we call it as cohesion. Means there is no dependency. Component C is not depending with any other component. Is it? Component C is performing its own operation. While performing its operation, which is not depending with any other components. So this concept we call it as cohesion, right? So why this coupling and cohesion plays major role? while designing a software system? That's what the question here, right? So why this cohesion and coupling plays major role here? Which should be high if as a designer, if you want to design a quality software system, then what should be high, what should be low here, right? As a designer, if you want to design a quality software system, right, then here in this case, coupling should be less, and cohesion should be high, right? As a designer, if you want to design a software system, right, your design software system is supposed to maintain better quality. For that, is it the design of your software system should maintain what here? The system which is going to be designed should maintain what here? Coupling should be less, very low, whereas cohesion should be high. Then only your design model, is it, which can maintain quality. That's why designers, they have to follow while designing a software system. Is it, they have to follow this particular thing. What is that? Coupling should be less and cohesion should be high, so that you are designing a software system which is maintaining quality. That is what the purpose of functional independence. So which one is maintaining here functional independence here? Cohesion is maintaining functional independence, whereas coupling is maintaining functional dependence. Right? Dependency between among components. Here, no dependency. So which one is maintaining functional independence here? Cohesion. That's why if you want to design a software system, cohesion should be high, whereas coupling should be less. Right? So that is about functional independence. Right? Coming to refinement. What is the importance of refinement? Refinement is one of the top-down design strategy. Refinement is one of the what here? Top-down design strategy. So from root to various other levels, top-down design strategy, right? And in this refinement, in the top-down design strategy, so what are the main root nodes gets divided into sub nodes, and all those supposed to be elaborated. Elaboration will take place. So that is what here refinement, through elaboration, So this top-down design strategy will take place here, right? So updating, simply we call it as updations at various levels that will take place. Then what is here refactoring? One of next fundamental concepts in design. So refactoring. So what's the importance of refactoring? So refactoring importance here is, if you want to improve the design model of a software system, for that you are trying for doing some changes. That change should not reflect on external behavior of your model. But improvement should take place. That process we call it as refactoring. Whenever you are trying for improving the quality of your design model, you are doing some changes. Those changes should not reflect on external behavior of your model. That process we call it as refactoring. That's the importance of refactoring, right? Next, we are already discussed uses of information hiding. Just now we have discussed information hiding. So it reduces the likelihood of side effects. That's a known thing to us. Limits the global impact of local design decisions. It emphasizes communication through control interfaces. Right? It discourages the use of global data. Right? And about architecture also we had discussed. So what is software architecture? Any software architecture is a collection of components and interfaces among components, right? The overall structure of the software and the ways in which that structure provides conceptual integrity for a system. So that is structural properties, which represents what here? Structural model of your software system. Extra functional properties. So what is the functionality of your software system architecture? So what are the functionalities your design architecture of a software system, design model of a software system will provide? Once you designed the architecture of your software system, what is meant by extra functional properties? You designed the architecture of a software system, right? What are the requirements for performance, reliability, availability of your architecture that can be represented, that is in the form of extra functional properties. Extra functional properties represents what here? What is the what is your architecture? The architecture which you designed, is it? So what are the requirements to achieve performance, reliability, availability of your architecture that can be represented with what here? Extra functional properties. And here structural properties. Structural properties represents what here? What are the various components of your architecture? Your architecture consists of what are the various components. So components which comes under structural properties means components which can be represented in the form of static, is it? So that's why which comes under structural, right? And families of related systems. So how patterns going to give solutions for your architecture, right? So the architectural design can be represented using one or more of a number of different models. So there are various models here. Structural models represents the architecture as an organizational collection of program components. Just now we had discussed components. Structural models represents components. So what is component? Component, physical replaceable part of a software system is called as component. Physical replaceable part of a software system is called as component. So as a designer, you are going to design a software system using UML, Unified Modeling Language, one of the object-oriented modeling language. So how to represent? What is the graphical representation of component in UML? This is what graphical representation of component in UML. For ATM application. So ATM user is one of the component, ATM user. That's it. Manager, one of the component. Database, which you are using, one of the component. Administrator, system administrator, one of the components. Means your architecture of a software system is a collection of components. So ATM application, is it? It's a collection of components. Online railway reservation system, which is a collection of components. Online gas booking system, which is a collection of components. That's what component. Physical replaceable part of a software system is called as component. Physical replaceable part of a software system is called as component. So structure, which represents structure. So component represents static part of your software system, right? And coming to framework models. What is the importance? Increases the level of design abstraction by attempting to identify repeatable architectural design frameworks that are encountered in similar types of applications. Framework models. Coming to dynamic models, so which addresses the behavioral aspects of the program architecture, indicating how the structure or system configuration may change as a function of external event. So dynamic behavior. Process models focuses on the design of the business or technical process that the system must accommodate. So functional models can be used to represent the functional hierarchy of a system. Functional model, functionality. Let's take here. So this is what the ATM application, banking ATM application. So what is functionality here, right? So actor, ATM user. Was it sending a request? Request was processed by the ATM application by connecting with whom here? Is it bank server, right? That's a known thing to us. So connecting with bank server and request was processed and sending response back in the form of service. So what is here functionality? What is the functionality? Request, response in the form of output. Is it which is provided, ATM application providing what is the output or what is the service to the ATM user? That is what here functional model represents. Functionality. What is the functionality of the ATM application? What is the functionality the ATM application is providing to the ATM user? Is it which can be represented with this functional models? That is what the importance of functional model, right? So patterns template, that's we already discussed what is pattern. Pattern which is going to give ready-made solutions, right? As a designer while designing a software system, is it? So if they want some ready-made solution, patterns can give ready-made solutions so that the designers, they can design a software system quickly, is it? With less time, with less design cost, is it? So that the organizations can run in benefit. That's why patterns plays a major role. Patterns template. So each and every pattern supposed to be given unique names. That is what we call it as pattern name, right? And also known as, right? And here motivation, what's the motivation behind usage of these patterns? Because patterns were giving ready-made solutions. What is the advantage with patterns? Design, design time is it, as well as design cost is less. So designers, they can design a software system quickly, is it, if they use pattern. That is what the motivation behind that, right? And applicability, where exactly you are going to apply. So if you want to design a software system, is it, their patterns required for us. If you want to implement a software system, their patterns if you are using. If you want to use already existing components from existing applications in your proposed application, that is what applicability. You are applying in design phase, is it, design of your application, you are applying at your implementation of your application, right? And participants, who are the various participants? Developers, users, is it, all these peoples, right? Collaborations, links. So what are the collaborations among them, right? Consequences, what's the output? If you use the pattern, what's the output, right? And related patterns. And refinements we have discussed, updates, that is top-down design strategy, which we already discussed, right? And abstraction also, about the abstraction also we had discussed, about refactoring also we had discussed. Refactoring is the process of changing a software system in such a way that it does not alter the external behavior of the code, it improves its internal structure. Whenever we are trying for changing the software system to improve the quality, because of that, its external behavior should not change. That is what refactoring we had discussed, right? And when software is refactored, the existing design is examined for redundancy, unused design elements, inefficient or unnecessary algorithms, poorly constructed or inappropriate data structures, or any other design failure that can be corrected to yield a better design, right? Next, we are going to discuss about architectural design. So what's the importance of this architectural design? We'll discuss. Software architecture. So what is software architecture? Any software architecture is a collection of components, interfaces among components, right? The software architecture of a program or computing system is the structure or structures of the system which comprise of software components, the external visible properties of those components, and the relationships among them. The architecture is not the operational software, rather it is a representation that enables you to what is the purpose of the architecture? So why architecture plays major role? How the architecture helps to other stakeholders? That's what the point here. So architecture can help in first way, analyze the effectiveness of the design in meeting its stated requirements. Architecture helps to the designers to better understand and to better achieve the requirements which is given by the clients. Once the stakeholders, if they observe the architecture, that's it. So architecture will help them, that's it, whether the client requirements specified properly or not. That way architecture helps to the stakeholders, designers especially, right? And second way is consider architectural alternatives at a stage when making design changes is still relatively easy. So for this software application, that's it. They develop, for example, architecture. So they can, they can do some alternate changes to the already existing architectures. They can improve it. Reduce the risks associated with the construction of the software. If the architecture was built properly, if the architecture is maintaining quality, if the architecture was designed, based on the client requirements, then there is no risk involved in the next phase. What is that next phase? Source code generation. Why? Architecture was designed based on the client needs, client requirements, so that source code can be generated properly. So there is no risk involved with source code generation. Next phase, construction of source code. Construction of software is nothing but generating source code by the programmers. Right. In the context of architectural design, a software component can be something as simple as a program module or an object-oriented class. That is what here. So any architecture is a collection of components and interfaces among components, right? And now observe here. The properties of components are those characteristics that are necessary for an understanding of the components interact with other components. So how one component is interacting with another component. This is component 1, right? And this is component 2, right? So with the help of component 2, with the help of what here? Interfaces. With the help of interfaces. Both components can communicate, right? At the architectural level, internal properties, details of an algorithm are not specified at architectural level. The relationship between the components can be simple as a procedure call from one module to another, as a complex as a database access protocol, right? Now, there is a distinct difference between the terms architecture and design. This we have to observe, we have to discuss. What is the difference between architecture and design? Right, that we'll discuss here, right? So a design is an instance of an architecture, similar to an object being an instance of a class. An object is it. So what is the difference between design and architecture? For example, consider the client-server architecture. So architecture will be one, is it? So from the single architecture, different design models can be generated, right? So I can design a network-centric software system in many different ways from the architecture. So I can design a software system either using Java platform, Java Enterprise Edition, or else I can design a software system using Microsoft .NET framework, or else I can design a software system using Python, using C++, Perl, PHP. That means to say client-server architecture, is it? So client-server is one of the single architecture. This client-server architecture can be designed in multiple ways. So architecture is single here. Is it? Architecture is single, right? From this single architecture, is it? You can design multiple design models, is it? You can design your software system, is it? By using various implementation languages, right? Right. So data design. So the design of a software architecture consists of two levels of the design. So data design and architectural design. So what is data design here? Data design enables you to represent the data component of the architecture in conventional systems and class definitions, encompassing attributes and operations in object-oriented systems. Whereas architectural design focuses on the representation of the structure of software components, their properties and interactions. Their properties and interactions. Why is architecture important? That's a question. Why architecture plays major role, right? There are three key reasons that software architecture is important. So what are those three key reasons here? Why architecture is important? Representations of software architecture are an enabler for communication between all parties, stakeholders, right? Designers, developers, clients, all these people, they can discuss, they can understand, is it based on the architecture of your software system? Architecture helps them to better understand. That is what, that's why architecture plays major role here, important, right? And architecture highlights early design decisions. So early design, which helps to the designers. Architecture will help to the designers to take the decisions early. And architecture constitutes a relatively small, intellectually graspable model of how the system is structured and how it is how its components work together. So which will give idea to the designers. So that's why architecture plays major role here, right? The architectural design model and the architectural patterns contained within it are transferable. Architectural descriptions here. Each of us has a mental image of what word architecture means here. In reality, however, it means different things to different implications. That different stakeholders will see an architecture from different viewpoints that are driven by their different sets of concerns. This implies that an architectural description is actually a set of work products that reflect different views of the system. So the IEEE Computer Society has proposed IEEE Standard 2000 recommended practice for architectural description of software intensive systems. The following objectives. What are those objectives here? First one is to establish a conceptual framework and vocabulary for use during design of software architecture, right? And to provide detailed guidelines for representing an architectural descriptions, and to encourage sound architectural design practices. This is about IEEE standards, right? Architectural decisions. We'll discuss the architectural genres will often dictate the specific architectural approaches to the structure that must be built. So what is the importance of these architectural genres that we'll discuss here? Within each category, we'll discuss about architectural genres. So these are all architectural genres here. Artificial intelligence, systems that simulate or augment human cognition, locomotion, or other organic processes. This is one of the, what we call it as here, architectural genre, architectural genres. Next is commercial and non-profit systems that are fundamental or to the operation of a business enterprise. Next is of communication systems that are providing infrastructure for transferring and managing data, for connecting users of that, or for presenting data at the edge of an infrastructure. Content authoring systems that are used to create or manipulate textual or multimedia artifacts. Devices, systems that interact with the physical world to provide some point services for an individual. Entertainment and sports, that is one of the architectural genres. All this. Financial, this is also one of the architectural genres. Games, right? Government, industrial, legal, medical, architectural genres. Military, operating systems. All these are architectural genres. Platforms, scientific, right, tools, various software tools, transportation, utilities, all these are architectural genres, right. Next, we are going to discuss one of the important concept. That is, one of the important concept is architectural styles. What are the various architectural styles that we'll discuss with the help of diagrammatic representation. So what is the importance of architectural styles that we'll discuss, and what are the various types of architectural styles that we'll discuss in detail, right? The software that is built for computer-based systems also exhibits one of many architectural styles. What are the various architectural styles that we'll discuss? Each style describes a system category that encompasses what here? First one is a set of components, example, a database, computational modules that perform a function required by a system, right? A set of components, connectors that enable communication, coordination and cooperation among components. So let's collection of components, right? Component 1, component 2, component 3, component 4. Right? First one is a set of components, all this, right? And here connections, communication among these components by using interfaces, right? And constraints that define how components can integrate to form the system. This is what integration among components. This is what complete software system. Software system, right? And semantic models, meaningful models that enables a designer to understand the overall properties of a system by analyzing the noun properties of its constituent parts. So what are the various architectural styles? Let us list out. First one is data-centered architecture. First one is of data-centered architecture. Second one is of data flow architecture. Third one is of call and return architecture. Fourth one is of object-oriented architecture. Fifth one is of layered architecture. Fifth one is of layered architecture. So architectural styles were classified into how many categories? 5 categories. What are those? First one is of data-centered architecture. Second one is of data flow architecture. Third one is of call and return architecture. Fourth one is of object-oriented architecture. Fifth one is of layered architecture. About these architectural styles, we'll discuss in detail, right? Data-centered architecture. So what's the importance of this data-centered architecture that we'll discuss? In data-centered architecture, the data was placed at central location, that we call it as data store. The data was stored at central location, right? And through repository or blackboard, by using repository or blackboard, that centrally stored data can be accessible and shared to multiple clients. So all these are the multiple clients, client software, right? Client software, client software, client software, client software. Here also all these clients, that's it, they can access their data. That means to say all multiple clients, right? They can store their data centrally at data store, right? Later, they can access their data or their module application, their component services, their application services, is it independently. So that is what the importance of data-centered architecture, right? So for example, client software 1, let's take, is it client 1 simply I can say, client 2, 3, 4, 5, 6, 7 and so on, nth client. Let's take, if you consider n as 100 clients, 1000 clients, 1 lakh, 1 crore clients means 1 crore clients, right? Multiple clients. All these clients, right, they stored their application, that's it, components in the data store, right? So, so now the point here is all these clients, they can access their application services. They can access their application services. What are the updates which were done at data store, is it centrally? Those updates can be given to all the clients through this repository or blackboard. So this blackboard or repository which can update what are the changes which has done at centrally stored data, is it those changes which can be provided to various clients by using repository or blackboard. Let's take client 1. Client 1 wants to change the existing component of his or her application. So client 1 can send a request, existing components can be removed, and client 1 can add new component to their application. So that change will not reflect on other client components or other client applications. That means to say each and every client independently, they can add the new components, is it? They can able to remove the existing components. They can do the operations independently. They can access their application services independently. Because of their changes, is it? No other clients will reflect. No other clients will get reflected. No other clients will get problem. Is it clear? Independently, each and every client, they can access their applications, they can modify their components, they can add new components, they can remove existing components. That's it. All those changes they can do independently. That's why data-centered architecture plays major role. Data-centered architecture, one of the architectural style, that is data-centered architecture plays major role. Right? This is about data-centered architecture. Coming to data flow architecture. So this data flow architecture, which consists of filter and pipes, So what this filter represents here? Filter represents component, right? Filter represents what here? Component, right? And this pipe represents what here? Filter represents component. Pipe represents what here? Pipe represents here what? Dispatching of message, is it? So message passer simply we call it as, is it? So now, what is the importance of this data flow architecture? When some input was given, that input was reached to this component, is it? And this component is going to produce some output, right? That output can be given as input to the next component. Again, is it, which is processed by this particular component 2. That component 2 is producing outputs. Is it, this component 2 output was given as input to remaining 4 components. Again, which will process and producing some output that is given to remaining components, is it? And which will give inputs that become output to these components, is it? That means to say, what is happening here? So what is the input or data which is given that is processing at multiple components and producing some output. So that is what the importance of data flow architecture. Next, we are going to discuss about call and return architecture. So what is the importance of call and return architecture? That we'll discuss here. Call and return architecture importance. So main program was gets divided into subprograms. Controller subprogram. Again, controller subprogram gets divided into application subprogram. Here also application subprogram. So call and return architecture. So main program gets divided into So we had discussed. So large complex application was gets divided into sub-programs. Again, sub-programs gets divided into sub-programs which can perform its own operations. After performing its own operations, that's it. Again, what will happen here? So some integration also will take place here. So that is what call and return architecture. Next, what is here fan out? What is meant by here fan out? Fan out means here the number of nodes that a particular node gets divided into is called as fan out. The number of nodes that a particular node gets divided into is called as what here? Fan out. What is fan out? Let's see. This is what the single node, right? Single node. Let's take this single node gets divided into two subnodes, was it? So this we call it as fan out, right? So the number of nodes that a particular node gets divided into, right? That is what fan out. Then what is fan in here? The number of nodes that combine and integrate to form a particular node, that is what we call it as fan in. Let's take node 1 and node 2. Both are going to migrate and producing one new node. This we call it as fan in, right? So that is what fan out and fan in, right? Object-oriented architecture. So the object-oriented architecture which consists of the components of a system encompasses data and operations that must be applied to manipulate the data. So object-oriented architecture which consists of in the form of objects and classes, right? So communication and coordination between components are accomplished via message passing. Next, we are going to discuss about layered architecture. What's the importance of this layered architecture? That we'll discuss. The importance of layered architecture, which consists of various layers: core layer, utility layer, application layer, user interface layer. So what's the importance of core layer? So core layer, which performs here, which consists of your operating system. So core layer, which consists of your operating system, which can manage the resources. That is what the importance of core layer. Inner layer, simply we call it as utility layer, which is going to provide utility related services. Application layer, which is going to provide application related services to the users. A user interface layer, which is going to interact with the user and providing services. That is what the importance of what here? Layered architecture. Architectural patterns, we had discussed the importance of patterns which will give ready-made solutions to the designers as well as developers, right? As the requirements model is developed, you will notice that the software must be address a number of broad problems that span the entire application, right? For example, the requirements model for virtually every e-commerce application is faced with the following problem. How do we offer a broad array of goods to broad array of customers and allow those customers to purchase our goods online? So e-commerce applications, so architectural patterns, which is giving what here ready-made solutions. So how to purchase, how to sell the products, So patterns, ready-made solutions, which can give give to the what here various organizations how to sell their products through online and all, right? So the requirements model also define a context in which these questions must be answered. For example, e-commerce business that sells of gold equipment to consume will operate in a different context than an e-commerce business that sells high-priced industrial equipment to medium and large corporations. In addition, a set of limitations and constraints may affect the way in which you address the problems to be solved. Architectural patterns addresses an application-specific problem within a specific context and under a set of limitations and constraints, right? The pattern proposes an architectural solution that can serve as the basis for architectural design. Most applications fit within a specific domain or genre, and that one or more architectural styles may be appropriate for that genre. For example, the overall architectural style for an application might be call and return, object-oriented, data center, we had discussed, right? Organization and refinement, because the designer process often leaves you with a number of architectural alternatives. It is important to establish a set of design criteria that can be used to assess an architectural design that is derived. The following questions provide insights into an architectural styles. What are those questions? Just see here. Control. How is control managed within the architecture? Does a distinct control hierarchy exist, and if so, what is the role of the components within this control hierarchy? Component which can perform some operations, right? How do components transfer control within the system? So components, they're supposed to communicate with the help of interfaces, right? How is control shared among components here? So components, so the one component wants to share information with another components via message passing, right? What is the control topology? So the geometric form that the control takes place. Is control synchronized, or do components operate here? These are all the questions. How are the data communicated between components? So through using interfaces. Is the flow of data continue, or data objects passed to the system sporadically? What is the model of data transfer? Are data passed from one component to another, or data available globally to shared among system components? We know global sharing. So data was available in globally means data was available, any component can use it. Whereas in another case here, one component can share information to another components. Right? Do data components, example a blackboard or repository, data center architecture we have saw there, exist, and if so, what is their role here? So the role of this blackboard or repository here is, what was the data which was updated centrally, that updated information can be shared among multiple clients so that they'll get the data. How do functional components interact with data components? So are data components passive active? Does the data components actively interact with other components in the system? How do data and control interaction within the system? So that is about the interaction among components. Next we are going to discuss component level design. So what is the importance of this component level design? So what is the purpose of this component level design? If you design a component, who will use this designed component? So which phase of SDLC will utilize the component level design? Once the components were designed, so the based on the component design only, implementation of a software system will take place. Implementation of a software system, right? Based on the component level design only, implementation of a software system will take place. Implementation of a software system will take place. That means to say, component level design helps to the programmers or developers to generate source code. If the component level design was designed properly, component level design was done elaborately, elaborated component level design means in detail component level design helps to the programmers to generate source code properly for the application. So that's why component level design plays major role. Right? So about this we'll discuss. Component level design is the definition and design of components and modules after the architectural design phases. So based on the architecture, component level design will take place. Component level design defines the data structures, algorithms. Component level design defines the what here? Data structures, right? Algorithms, interface characteristics, and communication mechanisms allocated to each component for the system development. So we already mentioned what is the graphical representation of component in UML. We discussed briefly about this UML, Unified Modeling Language. So what is the graphical representation of component in UML? This is what graphical representation of component in UML, right? This is what component, right? Right, so component level design defines what here? Data structures, algorithms, interface characteristics. One component wants to communicate with another component. What is required for us? Interfaces required, right? So communication mechanism, interface characteristics, communication mechanisms allocated to each component for the system development. A complete set of software components is defined during architectural design, but the internal data structures and processing details of each component are not represented at a level of abstraction that is close to code. UML specification, just now we had discussed it. UML specification of component is expressed as a modular, a deployable and replaceable part of a system that encapsulates implementation and exposes a set of interfaces. So just now we had discussed it, right? So UML, Unified Modeling Language, right? So what is the graphical representation of component in UML? Just now we had drawn, right? So this is what graphical representation of component in UML, graphical representation of component in UML, right? In UML, how to represent component? This is what graphical representation. UML specification component is expressed as a modular. Is it? This is component 1. I can here. Let's for ATM application. What might be the components? ATM application. For ATM application, what might be the components? Let's see. ATM user is one of the component. ATM user. ATM user. Right? Bank manager is one of the component. Manager, simply you can say here. Manager. Database is one of the component. Database is one of the component. Administrator is one of the component. Administrator, system admin. Let's take ATM application consists of, we identified 4 components, right? So which component is depending on which component here? ATM user, they are depending on database. Even bank manager also, they are depending on database because they want to view. Is it? Database consists of all the ATM user details. Is it? Customer or client details. So administrator also depending on whom here? So this is what dependency relationship in UML. So what is the importance of dependency here? One component is depending on another component, right? So here ATM user is a component depending on database component, right? So that is what here importance of component in UML. So which is a modular. Is it not like a modular? 1, 2, 3, 4, your ATM application was gets divided into modules. Deployable. So components. These components you can deploy. Where can you deploy these components? What is the need of components? A physical replaceable part of a software system is called as component. Means that software a small executable file. Example for components is what here? Small executable file. Is it? Your Java program. Is it clear? Your simple Java program. Your files, some executable files. These are all the examples, some libraries. Is it? Is it? So APIs, all these are the example for components. Is it clear? So you develop a simple program. That might be one program, that might be one more small program, that might be one more small program, all those programs which were what integrated, right? So those programs, you want to deploy your application, or is it? So where you supposed to deploy here? We call it as here, we call it as, is it? We call it as node. So on this node, these components supposed to be deployed. On this node, these components supposed to be deployed, right? So what is node here? What is mean by node? Node stands for standalone computer. Node represents what here? Standalone computer. Is it? Means laptop or desktop or server machine. Is it? Which is having all processing capabilities. So hardware resources, software resources in it, right? So configured machine, simply I can say. On that configured machine, you are deploying your software component, small component on it. So you are some files. Which is it? This standalone computer which can execute. That is what the meaning of what here? Deploying. You are deploying the software components on the hardware configured machine. So which can execute it. That is what the purpose of deployable and replaceable part of a system. So we already discussed what is component. Component is a physical replaceable part of a software system. Is it clear? So that is what here? Replaceable. A part of a system that encapsulates implementation and exposes a set of interfaces. Yes, these are all interfaces, right? And component views. Let's see here. Object oriented. O is nothing but what here? O represents what? Object oriented view. Object oriented view. O represents what here? Object oriented view. A component is a set of collaborating classes. A component is a set of collaborating classes. So what is the graphical representation of class and all? We'll discuss it anyhow. Conventional view. A component is a functional element of a program that incorporates processing logic, the internal data structures required to implement the processing logic, and an interface that enables the component to be invoked and data to be passed to it. Component level design includes the following actions. What the component level design consists of here? Identify design classes that corresponds to the problem domain. So what is the graphical representation of class in UML? Unified Modeling Language. So graphical representation of class can be represented with rectangle box, which consists of 3 compartments. That is class name, attributes, and operations. Class name, attributes, and operations, right? So identify component level design includes the following actions. What are those here? Identify design classes. That is one of the design class that corresponds to the problem domain, right? Identify infrastructure domain, right? Elaborate design class. So here let's take elaborate is nothing but what for ATM user. Let's take for ATM user, right? So class name is ATM user. ATM user. What are the attributes for ATM user here? ATM user name, address, mobile number, etc. There were many operations ATM user can do. What are the operations? Withdraw money, deposit money, was it? Check balance. These are all the operations. These are all the operations, right? So what exactly here? Elaborate design classes means not only just giving few attributes and operations. You have to give elaborated attributes and operations for ATM user. That is what elaborating the design class. That is what. So elaborated design class helpful to whom here? The programmer who is going to generate source code for them, right? That is what the purpose of elaborating design class. Elaborate design classes that are not acquired as reusable components, right? Specify message details. Identify interfaces, right? What are the various interfaces? Elaborate attributes, just now we had discussed it. Elaborate, add more number of attributes. And define your data types. So name, string, address, is it clear? Mobile number, integer, data types you have to specify, and data structures, right? Describe processing within each operation in detail. So just now we had discussed operations, withdraw, deposit, check balance, all these are the change the pin, all these are the operations, right? Describe processing within each operation in detail. Describe persistent data structures, databases and files. So that is in the form of component. Develop and elaborate behavioral representation for a class for a component. Elaborate deployment diagrams to provide additional implementation details. Deployment diagram. In UML, deployment diagram represents what here? Hardware configuration. Hardware configuration. So what is the graphical representation of deployment diagram? Simply I can say here, right? Cubic, right? So this is server 1 deployment diagram. Is it for this? This is a device, printer I can say here. And this is what the node, is it? Client machine, simply I can say client machine, is it? So this is what entire thing we call it as deployment diagram. This we call it as deployment diagram. So on this server machine only, the components which were developed with the developers which will be stored here. And what is the request which is sent by the client that will process. If manager, if they want to take print, they can take with using this machine. So that is what elaborate deployment diagrams to provide additional implementation details. Class elaboration, we'll discuss class elaboration. So class elaboration focuses on providing a detailed description of attributes. Just now we had discussed interfaces and methods before the development of the system activities. The following example provide a elaboration design class for a print job. Elaborated design class provide a detailed description of the attributes, interfaces and operations of the class. Let's see with the help of diagrammatic representation. Right. This is what analysis class. What is class name? Print job. Is it? So what are the attributes here? Number of pages, number of slides, paper type, magnification, production features. What are the operations? Compute job cost, pass job to printer, and design component. What is the graphical representation of component? We already discussed. This is what the graphical representation of component. This is the graphical representation of class. Class consists of 3 compartments: class name, attributes, operations. And this is what graphical representation of components, right? So how this component going to communicate with this particular class? So by using interface. This is what the graphical representation of interface here, this part, interface. This is interface 1. What is the name of the interface here? Compute job. What is the name of the component here? Print job. Print job is the component name. So compute job is one interface. And what is one more interface here? Initiate job is one more interface, right? 2 interfaces, right? And this is elaborated design class. So we are elaborating in detail, right? So compute job, one of the interface, that's it. This is what another way of, second way of representation of interface. Interface with tagged interface name. Interface is it followed by compute job is interface name. And what is interface? Interface is nothing but set of operations which is performed, is it? Which is going to provide to other systems. So some operations. So interface represents some set of operations. What are those operations here? Compute page cost, compute paper cost, compute product cost, compute total job cost. Is it? Interface. What is the name of the interface here? Initiate job here. Build work order, check priority, pass job to production. Pass job to production. Right? So what is the class name here? Print job. Right? So what are the attributes? Additionally, elaborated class. Elaborated class is, what is meant by elaboration here? Adding more number of attributes, adding more number of operations for already existing class that we call it as elaborated design class. This elaborated design class helpful to whom here? The programmers who are going to generate source code. Based on this elaborated design class, they can generate source code more easily. That is what the purpose of elaborating the design class, right? So now observe, these are two interfaces, interface 1, interface 2, right? And these two, with the help of these two interfaces here, communication will take place. So this is what the print job is a class, number of pages attribute, number of slides, paper type, paper weight, paper size, paper color, magnification, color requirements, production features, collation options, binding options, cover stock, bleed priority, total job cost, W1 number. What are the operations of this elaborated design class? So there are various operations here: compute page cost, compute paper cost, compute production cost, compute total job cost, build work order, right? Check priority, pass to top production. So these are all the operations. So the class which was more elaborated means added additional attributes and operations for the already existing class, so that we call it as elaborated design class, right? And design principles. What are the design principles, right? Let's see here. The design principles for component level design comprises of the following, right? So design by contract, open closed principle, subtype substitution, depend on abstractions, interface segregation, right? Design by contract. What is meant by design by contract? The relationship between a class and its clients can be viewed as a formal agreement expressing each party's rights and obligations. Consider the following list operations: public item remove index. It requires that the specified index is in the range 0 less than index less than size, and ensures that the element at the specified position in this list is removed. Subsequent elements are shifted to the left. One is subtracted from their indices, and the element that was removed is returned. Right? Open closed principle. What's the importance of open closed? A module should be open for extension, but closed for what here? Modification. There should always a room for extension without modifying the module. Right? The following module depicts a sensor module which performs the operations. What are those here? Read operation, enable operation, disable, test. Right? The module can be extended for sensing smoke, motion, heat, CO2, etc. Let's see here. What is the interface name here? Sensor is the interface. This sensor interface is going to perform what are the operations? Read, enable, disable, test. Right? Coming to detector, is it? So detector is one of the component, is it? So this is what is the relationship here? Dependency relationship in UML. Dependency relationship in UML. Detector, is it? Which is going to detect using sensors, right? And what are here? So this sensor: window, door sensor, smoke sensor, motion detector, heat sensor, CO2 sensor, right? Coming to substitutability, what is the importance of substitutability? Subclasses should be substitutable for base classes, means parent and child class. So parent class, attributes, operations, right? Similarly here, child class, attributes, operations, child class attributes operations, right? This is what the one of the relationship which we are using, generalization relationship in UML. So child class can acquire the properties of parent class. For that purpose, we are using, what is the name of the relationship here? Generalization relationship in where? UML. In UML, Unified Modeling Language. If you want to model parent and child classes, you have to use generalization relationship. Child can acquire the properties of parent. Child can be substitutable by parent. Can act as a parent. Can communicate with other classes. Can communicate with other classes also, right? That is class name, attributes, another class, operations, right? Right. So this is what subclasses should be substitutable for base classes. So, is it? Next, the subclasses derived from the base class should extend the functionalities of the base class. Just know what we have discussed, the concept, right? Dependency inversion. This is what dependency means. What here in UML? Dependency relationship depends on abstractions and interface segregation. Many client-specific interfaces are better than one general-purpose interface, right? Now observe here, security floor plan, right? So this is what the interface. What are the interface can perform some operations: place device, show device, group device, remote device. Is it? One more interface name is surveillance floor plan. Operations: place device, show device, group device, remote device, show flow, FOV, and show device ID. Right? What is floor plan here? Floor plan is a class. Is it having some set of attributes? What are the operations here? Place device, show device, group device, remote device, show FOV, show device ID. So this particular class which was implemented by using what here? Interfaces, interface 1 and interface 2. Cohesion, we have discussed what is meant by cohesion, right? Cohesion is nothing but what here? Single-mindedness. That means to say this is a component, single component which can perform its operation on its own. That is what cohesion. As a designer, while designing a software system, their modules supposed to maintain high cohesion, means modules should be designed independently. Among modules, dependency should not be there. Module should be independent. Then only the design model can produce high quality. That is what the importance of what here? Cohesion. That's the importance of cohesion, right? Cohesion implies that a single component or a class, just now we had discussed, this is a single component, right? So functional, layer cohesions, various types of cohesions, communicational cohesions, functional cohesions, various types of cohesions. Typically apply to operations where a module performs one and only one computation and then returns a result, right? So just observe here, camera is a class. What are the attributes here? Various attributes we can add. Operations, determine type, translation, display ID, display view, display zoom. These are all the operations, camera class. Combine some operations, camera attributes, is it? Determine type, translate location, display camera. Layer cohesion. Layer cohesion applies to packages, components, and classes. Is it? There, where exactly we can apply this layer cohesion, right? And this is what control panel, which can detectors, phone, mode run, tick on. And communicational cohesion. All operations that access the same data are defined within one class. So communicational cohesion. In general, such classes focus only on the data in cohesion, accessing and storing it. A student record class that adds, removes, updates, and accesses various fields of a student record for client components. And we have discussed coupling. So what is coupling? Coupling represents what here? So the coupling, for example, we already discussed about this. Component 1, there are two components, component 1, component 2. Component 1 is depending on component 2, at the same time component 2 also depending on component 1. When components were performing their operations, they are depending on each other. So that is what here coupling taken place. Dependency among components or dependency among modules is taken place. What is the problem here? When the modules were depending among them, quality cannot be maintained. When the components were depending among them while performing operations, is it? So quality cannot be taken place. So that's why while designing a software system, coupling should be very less. And what should be high then? Cohesion should be high. Then the designers, they can build quality design model, right? Which can be satisfied by the clients, right? That is what the importance of, so coupling, content coupling, common coupling, routine call coupling, type use coupling, inclusion or importing coupling, right? What's content coupling? It occurs when one component, is it? So surreptitiously modifies data that is internal to another component. That is what content coupling. Next is common coupling. It occurs when number of components all makes use of global variable. So component 1, 2, 3, for example, 5 components. All 5 components, they are using global data. Was it common data? Global data which was shared among all 5 components. That is what common coupling. Next, what is routine coupling here? So when certain types of coupling occurs routinely in object-oriented programming. So routine coupling we call it as. Routine call coupling. So occurs when one operation invokes another type use coupling. So occurs when component A uses a data type defined in component B. So component B which was already defined with data type, was it? The data type which was used by component A. That type of coupling we call it as routine call coupling. Steps 1 and 2, identify classes. Most classes from the problem domain are analysis classes created as part of the analysis model. The infrastructure design classes are introduced as components during architectural design. So class elaboration, we had discussed, specify message details when class or components collaborate, identify appropriate interfaces for each component, elaborate attributes and define data structures required to implement, describe processing flow within each operation in detail. Collaboration in detail. Messages can be elaborated by expanding their syntax in the following manner. So this is what the syntax, is it? So sequence expressions. So return value, message name, arguments, the following example. Production job depicts the collaboration details for job production module. Just see production job. So work order, was it? Job queue, right? And coming to appropriate interfaces. So what are the interfaces here? Job description one interface, job queue also one interface, and this is what production job and compute job interface. Coming to elaborate attributes, we know what is meant by attributes. So ATM user is a class, attributes, adding more number of attributes, is it? Not only just ATM user name, mobile number, address, other details also supposed to be added. That is what elaborate attributes we call it as, right? And coming to describe the processing flow. Process flow is described in detail using activity diagram. So what is the importance of activity diagram? So flow of data from one activity to another activity. Elaborate behavior, necessary to model the behavior of a design class. So how the design class is behaving, right? So when some event occurred, transition is triggered from one state to another state, right? And algorithm design model, what is the importance of this algorithm design model that we will discuss? It represents at a level of detail that can reviewed for quality. So algorithms can be represented using graphical, is it? Pseudocode. Algorithms can be defined by using program design language, PDL, programming languages. Object-oriented design, what is the importance of object-oriented design? What are the characteristics? Object-oriented design is a collection of objects and classes. What are the characteristics of this object-oriented design? Objects are abstraction of real-world entities, right? So objects were existing physically, whereas class were exists logically, right? Objects are independent and encapsulate state and representation information. System functionality is expressed in terms of object services. Shared data areas are eliminated. Objects may distributed and may execute sequentially or parallelly. So architectural design, just observe here architectural design. And architectural design begins the software to be developed must be put into context, that is design should define the external entities, other systems, devices, people that the software interacts with, the nature of the interaction, right? Representing the system in context, right? Superordinate systems, subordinate systems, peer level systems, actors, that we'll see with the help of diagram. So superordinate system which can use the target system, superordinate systems, right, which can use the target systems. Peer systems, so peer-to-peer systems. So here all the systems were having equal priority, right? And coming to subordinate systems, was it target system, which is this target system is depends on subordinate systems. And actors, they are trying for using services from the target system. That is what the importance of actors here. Users, simply we call them as users. and architectural context diagram for the safe home security function. So safe home security system, target system, is it, that is security function, is it. So what it consists of here? Control panel, home owner. So home owner remotely they can operate their safe home security system. Is it clear? So here internet based system. So the home owner. So already fixed this what here, safe home security system, and remotely the owner can operate if any unauthorized person trying for entering into their home. Was it clear? The safe home security system will give information to the homeowner, so homeowner can alert to the neighbors. Is it? So that way the home can be safe, right? So the sensors will sense it. Was it? Using sensors which will pass the information, which will sense, and surveillance function. So surveillance which will get the information, right? So safe home product. So this is what the importance of safe home security system. Defining architect, node, detector, indicator, right, controller. This is what controller. So what is the importance of this here? This we call it as aggregation in UML, one of the relationship, aggregation relationship. So what is the importance of this aggregation relationship? So this is what controller is a complete class. From that controller complete class, if you want to specify small part from this, that is node, then we have to use this aggregation relationship. That is what the importance of aggregation, right? And this is what here generalization, this relationship in UML. In UML, Unified Modeling Language, this relationship is called as generalization relationship. Generalization relationship. Generalization relationship. So what is the purpose of generalization relationship? If you want to model parent and child classes, then you have to use generalization. So node is a parent, detector and indicator are child classes. That's it. Then we have to use what here? Generalization, right? So child can be subtold to a parent, can act as a parent, can communicate with controller class. That is what the importance of. So here, what are the childs here? Detector and indicator are child, is it? Whereas node is a parent. That's why we had used here generalization relationship. UML relationship for safe home security function archetypes. Refining the architecture into components. External communication management, control panel processing, detector management, alarm processing. Just see here, safe home security system, safe home executive, right? External communication management, GUI, graphical user interface, internet interface, security, function selection, right? Home management, surveillance, security, control panel, detector management, alarm processing. So what exactly here? Safe home security system is a collection of components. Is it? Safe home security system is a collection of components and interfaces among components, relationships, all this, right? So that is what safe home security system is, a collection of components. These are all the components in UML, right? So that is what safe home security system is, it main large class. These are all subclasses: external communication management, GUI, interior interface, internet interface, security, control panel processing, detector management, surveillance, home management, alarm processing, right? So overall architectural structure for safe home with top level components. These are all the components. So entire safe home security system is was represented in the form of components and interfaces among components, right? So describing instantiation of the system. So an actual instantiation of this architecture is developed for the purpose of applied to a specific problem with the intent of demonstrating that the structure and components are appropriate. So this is what safe home executive, external communication management, was it? GUI, internet interface, security, control panel processing. More detail we are giving here. Keypad processing, an instantiation of the security function with component elaboration, more elaborated details. So which is what previously is it elaborated here? No proper elaboration in this, right? So whereas coming to here, more elaborated means giving more detailed. Is it clear? So safe home executive, more elaborated. Here also more elaborated. Hierarchy was followed here properly. Alarm. So phone communication, alarm, right? Detector management. So scheduler, sensor, and coming to security, control panel processing. Right, keypad processing, is it? CD display processing, and here is GUI, internet interface, external communication management, safe home executive, right? So thank you, one and all. Nikhil? Nikhil?